In problem 4, we're looking at a graph of our velocity, where positive velocities are taking us away from home and negative velocities are taking us towards home. So this is a graph of velocity. So this is the graph of our rate of change of position. Here we are with positive velocities driving away from home for 6 hours. And then between 6 and 10 hours, we're driving back towards home. So this is we have readings every 2 hours. All right, so I'm gonna want that there. The positive velocities indicate that we were driving, just moving away from home. We don't know what kind of trip this is. The positive velocities where we are moving away from home, and the negative velocities mean we're moving towards home. So it looks like between 0 and 6 hours, we were riding away from home, and between 6 and 10 hours, we were headed back home. So from 0 to 6, our distance is increasing, and then from 6 to 10, our distance is decreasing, and the area will tell us how much. So what we want to do is calculate the area under the curve for both of these parts. So let's calculate all these areas. I'm going to calculate them as trapezoids. So the graph looks all very curvy and all, but I'm going to just calculate using straight lines. I could do a left and right and approximate things in the middle, but I'm just going to use trapezoids just for my own convenience. Oh, I guess this one from 4 to 6 is going to be a triangle. So here's us riding away from home. So I'm just going to label them A1, Area 2, and Area 3. So Area 1 will be a trapezoid, will be the average of the two heights, 15 and 20, multiplied by the change in time, the delta t, which is 2. So let's calculate that. So 15 and 20, I'm going to calculate it for 15 and 20 is 35 kilometers. So it looks like in the first 2 hours, we traveled approximately 35 kilometers. We go to calculate A2 and we'll do the same thing. It's approximately a trapezoid, so I'll do 1/2 base 1 and base 2. Oops. I said 2 and I wrote 2. That's times the delta t, which is 2, and we have another 35 kilometers. What we should note is how if we started at home, we are now 70 kilometers away from home. And then we start to realize that we've been riding away for a while, so we're still riding away, but we're slowing down quite a bit. So in A3, it's a triangle, so I'll just do 1/2 the base times the height. So the height is a 15, and the base is still 2. So between 4 and 6 hours, we've traveled another 15 kilometers away from home. Now, between 6 hours and 8 hours, at 6 hours, we've turned around and we are headed back home. So between 6 and 8, we're riding away from home. We'll call that A4. And A4 is going to be a triangle, so 1/2 the base, which I called -7, which may be a problem, and a height of 2, or a base of 2 anyway. And we got -7 kilometers. So after we are now 85 kilometers away, and between hours 6 and 8, we go 7 kilometers the other direction, because our velocity is negative, and negative velocities are taking us towards home. And then finally, here's A5, which is back to being a trapezoid. So the average of the bases, 7, -7, and -10, times the height of 2, and we get -17 kilometers. So between hour 0 and hour 6, it looks like we travel 85 kilometers from home. And then between hours 6 and 10, we travel 24 kilometers in the other direction. Questions? So that would be what, 90? 90 minus the 24. So it should be 66 kilometers away from home. And I think 66 is actually within 2% of what they claim the answer to be 65. So clearly, they're saying that on this scale, it's perfectly appropriate to say negative 7.5. I would strongly disagree with being able to go down to the nearest tenth when you have marks every 5 units. Any questions?
Where does the 66 come from? Because isn't it 85 minus 7 minus 17?
Oh, yeah. So 85. I put 90. So 35, 35 is 70, 85. 85 minus 24. We would be 61. So we're out of tolerance. I'm not sure where they're getting. Oh, they probably, at 4, maybe instead of 15, they said something more. So they don't even explain in their solution. So if you have not done your third guess at this one, it's 65, 6, that one you should get, and 90. Those are the 3 solutions. 65, 6, and 90 are the answer. Because they think you're 90 kilometers from home, and I said you are 85. And I think the book's approximation of what's happening at 4 is higher. Any questions? You're farthest from home at 6 hours. So you start off 0 kilometers from home. So these are the 3 answers. At 0, you start off, this is your distance from home. You start off 0. These values are not where you are. These are how far you've gone in the last 2 hours. So at 2 hours, you've increased by 35, and you're now at 35 at 2 hours. And then from 2 to 4, you've increased by 35, and now you're at 70. And then from 4 to 6, you've increased by 15, and you're at 85. Then from 6 to 8, you've decreased by 7. And so at 8 hours, you're at 78. And then between 8 and 10 hours, you're minus 17. You've gone minus 17 kilometers. So 78 minus 7 is 61. So this is your distance from home. The calculations that we have here are not how far you are from home. These are the changes in position during those 2-hour blocks. Not your position, the change in position. Yikes. That's your change in position, not the position itself. It's your change in position. So it's not your position, it's the change in position. And this makes sense because between 0 and 6, our function is increasing because our derivative is positive. Between 6 and 10, our function is decreasing. So at 6 is where the function goes from increasing to decreasing. So we have a critical point at 6. That's where the function goes from increasing to decreasing. And this critical point is going to be a local max because the function changes from increasing to decreasing. Because the derivative goes positive to negative. So the function goes increasing to decreasing.
So it's not an inflection point, it's a local maximum.
It's a local maximum. There's a local maximum at 6 because that's where the derivative is equal to 0. Any other questions? Great. Let's pause the video here and look at some more problems.